Okay, so let's take a look at it. And I realize the numbers might be a little challenging, but 729 is actually a perfect square. And I'm going to say it's 27 squared. That's equal to 729. Again, I don't mind using calculators, but if you want to do it by hand, 27 times 27, well, 7 times 7 is 49. 7 times 2 is 14, that's 18. 2 times 7 is 14. 2 times 4 is 4, and then you get a 5. Let's see what you get over here, 9. Let's see, 8 and 4 is 12. 5, 6, 7, 29, as expected, all right? So that's kind of good news that we saw the perfect square. And what I'm going to do now is write that down for you. So this is a difference of perfect squares, and that's going to be 27 minus n cubed, and then 27 plus n cubed. All right, so I'm looking at that, and we got it partially factored. That does work out, by the way. And I'm noticing now I got the difference in sum of perfect cubes, right? So first I did the squares, now I'm going to do the cubes. And what's that going to be? Well, let's write this down. 3 minus n. Then you're going to get, let's see, 9 plus 3n plus n squared. That's this guy factored. Let's do the other guy going to be, that's going to be 3 plus n. And then what do you see over there? You would see, let's see, you would see 9 minus 3n plus n squared. And I'm going to say I'm done there, all right? So, you know, certainly I say I'm done. I may not be done, I may have made a mistake. And let's take a look at the key. All right, now I notice the key looks a little bit different, but not everywhere. But I'll go through that with you. I definitely see 3 plus n. I definitely see 9 minus 3n plus n squared. I see 3 minus n. I see that, and I see this over here. Again, our intent is not to confuse you, but a lot of times what happens with answer keys is they don't put down, you know, the variety of answers that are possible. But I do want to claim that if I were looking at this problem over here, you know, one thing I could do with the problem is I want to point out what I mean by that. I'm going to erase this over here now. This is good. We know our answer that we gave is good. But I want to point out they gave an alternative answer. And someone says, why would they do that? Well, it looks like the impression they're giving me is they like to write things in descending powers of n. So I see this thing is written in descending powers. Whoops, sorry about that. I made a mistake there. I see that this thing is written in descending powers of n right over here. So that's n squared plus 3n plus 9. Not a problem. I see that this thing here is written in descending powers of n squared minus 3n plus 9. And this one over here, 3 plus n, in descending powers of n would be n plus 3. And I definitely see that there. Now, to write this one in descending powers of n, what you do is you factor out a minus 1, and what do you get? You would get n minus 3. And I do see the n minus 3 here, and I do see the coefficient of minus. That's a minus 1, actually. All right? So alternative answers sometimes are confusing to students, but you should struggle to make sure that your answer is listed in my answer key. Again, if you have another answer key, you should probably be struggling with why your answer might look different than the others. And sometimes they just write things differently, right? They're equivalent, but they look different. All right, thank you.